All right, let's dive into the world of machine learning. And to spice things up, we're going to use the world of Naruto to explain it all.
You might be wondering how ninjas and algorithms could possibly connect.
Yeah, how can those two things even relate?
But trust me, the connections are there.
Okay, so you're interested in machine learning but don't want to get lost in all the tech jargon.
All right.
Well, think of it this way. Remember how ninjas specialize in different paths, like taijutsu or jinjutsu or even senjutsu?
Uh-huh.
Machine learning has similar paths
Like different schools of thought.
called supervised, unsupervised, and reinforcement learning.
Each path or type of learning has its own strengths,
Right.
and it's best suited for certain tasks.
Just like choosing the right jutsu for the mission.
Exactly.
So first, let's talk about supervised learning.
Okay.
Picture this. A brand new Genin, fresh from the academy training under Kakashi.
Hmm.
He gives them clear instructions, shows them the moves,
Right.
and then critiques their performance.
Yeah.
That's basically supervised learning.
Like a good sensei.
The algorithm learns from labeled data.
It's like having a scroll with all the right answers, right?
Okay.
Each data point is tagged with the correct outcome.
Okay.
The algorithm studies these examples and learns to make predictions for new data.
Ah, so it's like Naruto mastering the Rasengan under Jiraiya's guidance.
Exactly.
He had those steps to follow and Jiraiya's feedback along the way,
Yeah.
which helped him learn the technique.
Uh-huh.
So within supervised learning, there are different jujitsus
Different techniques.
or algorithms for specific tasks.
Right, let's start with linear regression.
Okay.
This one's all about predicting a number based on existing data.
Okay.
So imagine trying to predict the power of a Chidori based on Kakashi's chakra level.
So you'd gather data on Kakashi's chakra levels and the corresponding power of his Chidori in different battles,
Exactly.
and then use linear regression to find the relationship between the two.
Yeah, it's like figuring out that for every unit increase in Kakashi's chakra, the Chidori's power increases by a certain amount.
Oh, so then you could estimate the power of future Chidori just by knowing his chakra level.
Right.
Now, what about logistic regression?
Yeah.
That's used for yes-no predictions.
Exactly. Like, let's say you want to predict whether a ninja will pass the Chunin exams.
Okay.
You'd look at their skills, their performance in missions, and other factors.
Yeah.
Logistic regression helps determine the probability of them passing or failing.
So it's like analyzing a ninja's strengths and weaknesses
Yes.
to figure out their chances of passing the exams.
Precisely. Think of it as drawing a boundary that separates those who are likely to pass from those who are not.
So we've got linear regression for predicting numbers
Uh-huh.
and logistic regression for yes-no prediction.
Yeah.
What other tricks does supervised learning have?
Well, there are decision trees.
Okay.
These are kind of like a ninja's strategic mind at work.
Okay.
So imagine Shikamaru analyzing a battlefield.
Mm-hmm.
He breaks down the situation into smaller decisions, considering all the possible moves and their consequences.
So each decision leads to a different outcome.
Exactly, like branching paths on a tree.
Right.
It's a way to handle complex problems by making a series of simpler choices
Gotcha.
based on the information available.
And then there are support vector machines.
Yeah.
They sound pretty intense.
They do have a complex name, but the idea is pretty simple.
Okay.
Imagine trying to separate two groups of ninjas, those specializing in taijutsu
Okay.
and those who excel at jinjutsu.
So like you're drawing a line between those two specializations.
Yes, support vector machines find the best boundary that maximizes the separation between the groups.
To make sure they're as distinct as possible.
Exactly. It's a powerful technique for classification.
That makes sense. It's like separating two different fighting styles based on their unique characteristics.
Right.
But even the most skilled ninja can make mistakes.
That's true.
Supervised learning has its limitations too.
Yeah.
We talked about overfitting earlier.
Yeah.
It's like a ninja who only trains against one specific opponent. They might get really good at defeating that one opponent, but then struggle against anyone else.
That's a great analogy. Overfitting is when the algorithm becomes too specialized to the data it was trained on.
So it loses its flexibility.
Yeah, it loses its ability to generalize and make accurate predictions on new data.
So just like a ninja needs a balanced training regimen,
Yes,
supervised learning algorithms need diverse data to avoid overfitting.
absolutely. It's all about finding the right balance between accuracy and generalization.
So the algorithm can adapt to new situations.
Exactly. Welcome back to our deep dive into machine learning, where we're comparing it to the world of Naruto.
Last time we talked about supervised learning,
Mm-hmm.
which is like having a sensei to guide you.
Right.
Now let's move on to unsupervised learning,
Okay.
where the algorithm has to figure things out on its own.
Yeah, unsupervised learning is all about finding hidden patterns in data
Okay.
without any instructions.
Like a ninja training in the wild, just observing nature
Exactly.
and developing their own techniques.
Yeah. It's like self-discovery for algorithms.
No sensei, no scrolls, just pure exploration.
Right. And one of the key techniques in unsupervised learning is clustering.
Clustering.
It's like grouping ninjas who have similar fighting styles.
Oh, so you could have a cluster of taijutsu specialists like Rock Lee and Mike Guy, and another for genjutsu masters like Itachi and Sasuke.
Exactly. The algorithm looks for those similarities in the data.
Okay.
And groups the data points together without knowing what those groups should be beforehand.
Wow, that's pretty amazing.
It's like the algorithm is uncovering hidden connections.
That we might not even know about.
Exactly.
Okay, so clustering groups, similar data points.
Right.
What else is there?
Another technique is dimensionality reduction.
Dimensionality reduction. That sounds complicated.
Think of it like a ninja focusing their chakra to enhance their techniques.
So they're simplifying their chakra control for better results.
Exactly. Dimensionality reduction is about simplifying data without losing important information.
Okay, so it's like condensing a giant scroll into a smaller one, but keeping all the key knowledge.
Exactly.
I can see how that would be useful, especially for analyzing big data sets.
It helps us focus on the important parts.
Like finding the signal in all the noise.
Right. It makes it easier to visualize and understand complex relationships.
So we've got clustering to group similar data.
Yes.
And dimensionality reduction to simplify data. Anything else?
Well, there's also anomaly detection.
Anomaly detection.
Yeah, it's like a ninja sensing of disturbance.
Like a security system for your data.
Exactly. A way to spot threats or anomalies.
That could cause trouble.
Right.
Unsupervised learning is a powerful tool.
It is.
It's all about letting the algorithm guide us to new insights
that we might not have found on our own.
So we talked about supervised and unsupervised learning.
Yeah.
Now we've got one more path to cover. Reinforcement learning.
Oh, yes.
It's like the rogue ninja of machine learning.
You could say that.
It's all about learning through experience.
Yeah. Exactly, just like a rogue ninja honing their skills.
So no sensei, no labeled data.
Right.
Just pure experience.
Exactly. In reinforcement, learning the algorithm interacts with its environment.
Okay.
And gets feedback in the form of rewards or penalties.
So it's like Naruto learning to control the nine-tails chakra.
That's a great example.
He had to experiment, adapt.
And learn from his mistakes.
So the algorithm is always trying to get those rewards and avoid penalties.
Exactly, just like a ninja trying to become stronger.
So it's not just about finding patterns in data.
No.
It's about learning how to navigate a changing environment.
You got it.
And that makes it really good for tasks like playing games.
Yes, where the algorithm needs to make decisions.
To win.
And exactly like figuring out the best moves in a game of shogi.
Or like a robot learning to walk in the real world. This is all so fascinating.
It is.
It's amazing to see all the different ways these learning styles can be used. Welcome back to our final part of this deep dive into machine learning.
It's been quite a journey.
We've gone through these different learning paths.
Using the Naruto universe as our inspiration.
Right. Now let's see how machine learning is impacting the real world.
Well, we actually interact with machine learning every day without even realizing it.
Really?
Yeah, like those recommendations you get on streaming platforms or online stores.
Oh, yeah.
That's machine learning.
It is?
Helping you discover new things you might enjoy.
So it's kind of like a jujitsu.
Yeah.
That predicts what a ninja would like based on their past missions.
Exactly. These recommender systems analyze your past choices.
Okay.
Like a Jonin assessing a Genin's skills.
Right.
And then suggest things you might find interesting.
Huh. It's amazing how those systems seem to know me so well.
Right.
I never thought about it as machine learning before.
It's all about recognizing patterns and making predictions.
Oh.
The algorithms learn from your behavior.
To make those suggestions.
Exactly.
But what about healthcare?
Yeah.
We talk about how machine learning could assist medical ninjas. But how does that actually work in the real world?
So imagine a medical ninja using their biokugan to see inside a patient.
Okay.
To find injuries.
Right.
Machine learning can kind of do the same thing.
Really?
By analyzing medical images like X-rays and CT scans.
Well, it's like giving doctors superpowers.
In a way, yeah. Machine learning can help find things a human might miss.
Oh, so it could lead to earlier diagnosis and better treatment.
Exactly.
That's incredible.
And it's not just image analysis.
No.
Machine learning can also help predict patient outcomes.
No.
Based on their medical history,
Correct.
their lifestyle, and even their genetics.
Wow. So it can personalize treatment plans?
And improve chances of recovery.
That's pretty
There's a
amazing.
powerful tool that's getting better all the time.
What other areas are being changed by machine learning?
Oh, machine learning is everywhere.
Really?
From self-driving cars to financial algorithms.
Wow.
It's really transforming so many industries.
It's incredible to think about all the possibilities for the future.
We've only scratched the surface today.
Right.
The world of machine learning is vast,
Yeah.
and it's always evolving.
Just like a ninja's journey never ends.
Exactly.
So we've come to the end of our deep dive into machine learning.
Through the world of Naruto.
We've seen how supervised, unsupervised, and reinforcement learning are like different ninja training styles.
Each with their own strength.
We've also seen how it's being used to solve real-world problems.
In healthcare,
Right.
entertainment,
Yeah.
and finance.
It's important to use these tools responsibly.
Absolutely.
Thanks for joining us on this incredible journey,
We hope you learned something new.
and that you're inspired to learn more about machine learning.
It's an amazing field.
Until next time, on the Deep Dive